here are some potential pitfalls when you use statistics. These are the common mistakes when people use statistics, and we should be careful about these. The first one is about correlation, which we'll talk about in the next chapter, and causation. So what's a correlation? Correlation means you have two variables, two things, and they are related. For example, if you have height and weight for a person, right? In general, if the height is bigger, the weight tend to be bigger because you got, this person has more muscles and bones, so the weight tend to be bigger. And in another example, if you have a car, right? It has mpg. It also has a weight, and these two are also related. If the weight is smaller, if the car is lighter, its mpg tend to be higher. The mileage per gallon tends to be higher because it's more energy efficient, right? It's lighter. So that's correlation. Simply means they have some relationship. These two variables have some relationship. And causation means they have this causal effect. One is the reason of the other one. One leads to the other one, right? So for example, if you eat, you're not hungry. So that's causation. Eating is the cause that you are not hungry. But in statistics, correlation doesn't imply causation. So be very careful about that. And here's a very funny example. There are two variables. One is the US spending on science, space, and technology. The other one is the number of suicides by hanging, strangulation, and suffocation. And these two variables are closely related. Well, you can see from this plot. From 1999 to 2009, right? You have the number for each. The red dot represent the spending. The black dot represent suicide. So these two have a very close relationship. They increase at the same pace, and that they are almost identical. That means they have some correlation. If the spending is higher, that means if you go, as time goes on, you spend more money on these reasons, then there's more suicides. But there's no causation. The spending is not the reason that you have more suicides, or the other way. Right? So if there is a causal effect here, then maybe we should spend less on these three things, on science, space, and technology, in order to have a smaller number of suicides. If they have causal effect, if they have causation. But that's not true. So even though they have correlation, there's no causation between these two variables. Another one is sometimes people tend to report the data in a wrong way, in their desired way. So if possible, you should measure instead of just write down the number from the respondent. Right? For example, if you are overweight, right, and your weight is higher than it should be, but when you report the weight, maybe you want to reduce this number, and you run it down, and sometimes people run it down by a lot. So that's the actual weight, and you report something like this. So this is not accurate, and if you use that data, you get wrong results. So if possible, do the measurement yourself instead of get the number from just by from the responder. Sometimes you could have this pitfall with loaded questions. People want to ask some questions that could give you the wrong impression, or they want to lead you to a certain answer. For example, have you stopped mistreating your pet? No matter what you answer, you will be in trouble. So this is a very bad question. This is a very loaded question. If you answer yes, then it means you used to mistreat your pet, even though you stop now. But if you answer no, that means it's even worse. Do you actually support this terrible politician? So they want you to answer no for this question because they manipulate this question in a certain way. Before you hit the other car, had it already entered the cross street? So the person already have the assumption that you hit the other car. That's your fault. Okay, so no matter what you answer, it's the answer is already there. You're the people who did the wrong thing. So that's also loaded. From the textbook, 2 questions are asked. They're basically the same thing, but you get different responses because the way the question is asked. Should the president have the line item veto to eliminate waste? Because eliminated waste is a good thing, so people, almost everybody answered yes. So the president could have the line item veto. But if the question is should the president have the line item veto or not, right? So they want to think maybe this is not a good thing, then you should answer no. And then many people answer no. So that's also loaded. Another thing you need to be careful about is non-responses. Not everybody will answer the questionnaire. In fact, many people wouldn't answer because it could be a spam, it could be they're worried about their privacy, so they don't really answer the questionnaire. So a non-response occurs when someone either refuses to respond to a survey question or is unavailable. This is one example from Wikipedia. Suppose one select a sample of 1,000 managers, and they want to know their workload. Now, if the manager is very busy with a heavy workload, then there's no time to answer this question. Maybe it would take 30 minutes. I don't have 30 minutes to answer this, so I will skip. Or if the manager has a very low workload, then they don't really want to answer this questionnaire because if they say I have a very low workload, and if other people saw that, then they may think this manager is not very useful, right? They could be laid off, right? Because they don't really work much. So in this case, they also tend to give a non-response. Okay, so you will give non-responsive from many different reasons, and then people who refuse to respond tend to be different from those who do not. Right? If I ask you a question, say, do you use drugs? If you don't, then maybe you just say I don't. Right? If you do, and you think this is not a very good thing, then maybe you will refuse to answer, or you can just answer no. So you basically lied. Right? So that's something you need to be careful about. The last thing is about percentage. That's something we should know from maybe high school or other places, but I just want to refresh your memory. So percentage is percentage, right? It's the number with the percentage symbol, and you can go from percentage, decimal, fraction, they all represent numerical values, and you can go back and forth from one to the other. And if you want to have a percentage, you simply multiply by 100%. For example, if you have 0.12, right, this is decimal. If you want to go for a percentage, you simply multiply by 100%. And 0.12 times 100 give you 12. So 12, and then you just keep the percent symbol. It's 12%. If you want to go backwards, say 50%, and you simply take 50 divided by percent, that's 100. So divided by 100, that's 0.5. So 50% is 0.5. So you can go from decimal to percentage or fraction to percentage. You just convert to decimal first, then go to percentage, or you can go from percentage to decimal. So these are very simple procedure. You should know this. All right, now that's section 1.1. Basically, I just give you some very simple concepts, and hopefully through those examples, you understand those concepts well. And now you can go ahead and do the homework questions. Okay. In fact, I have 3 questions here. These are from the exercise of the textbook. Let's go through these 3 very quickly, and that will help you do the homework questions. The first one is the potato problem. In a poll sponsored by the Idaho Potato Commission, 1,000 adults were asked to select their favorite vegetables, and the favorite choice is potato. Do you trust this number, 26%, or do you trust potato is the most popular vegetable or not? Maybe yes, but since this poll is sponsored by Idaho Potato Commission, I don't really trust that. So the answer may be biased, right? They may choose people from, some potato club or something, then they tend to answer potato. But in fact, this may not be the truth for all people in the state or in the whole country, right? Because if this is a poll sponsored by Broccoli Commission or whatever, then the answer may be broccoli. So I don't really trust this number. There's some problem with this poll. Healthy water problem. In a USA Today online poll, 951 internet users choose to respond, and 57% of them choose bottled water over tap water. Do you think this is true for the general population? Maybe not, because this is a voluntary response sample. Right? You can choose whether to be included in the sample or not. Right? They are internet polls. And also, since younger people tend to use internet more than older people, right? This number may be just some property of the younger ones, not the older ones. So should be careful about that. Motorcycles and sour cream. In recent years, there has been a strong correlation between per capita consumption of sour cream and the numbers of motorcycle riders killed in accidents. So these two have a very strong relationship, but there's no causal effect. One is not the cause of the other. So you cannot just say we should reduce the consumption of sour cream in order to reduce the motorcycle fatalities. This is not true. Right? They're not cause and effect. So this is not a good conclusion.